So hello everyone. I want to just give a quick introduction to the three types of compounds as we're taking a look at chemical bonds. The three main types are ionic bonds, covalent bonds, and metallic bonds. And here's just a little introduction of the difference between the three. Ionic compounds, we'll just taking a look at regular old sodium chloride, covalent, sugar, and metallic, tin. So with ionic compounds, we have sodium ions and chloride ions that are attached to each other. With sugar, there's covalent bonds in between all these carbons, hydrogens, and oxygens. And with metallic, you've got individual ions of the metals surrounded by their valence electrons that are holding them together. That's the sea of electrons. So first we're going to take a look at their conductivity. Do they conduct electricity in the solid form? So we've got a little probe that will sound a bell or a buzz when it is conducting electricity, and we'll test each one of these to see if they conduct. First we test the salt, and you can see it doesn't conduct. We test the sugar, you can see it doesn't conduct. But the tin, not surprisingly, does conduct electricity. So we'll say no for ionic, no for covalent, and yes for metallic bonds in the solid form. But what about if we put them in water? Now you know that salt will dissolve in water, and sugar will dissolve in water. Metals don't dissolve in water, so testing the metals, that's kind of a silly thing, but we'll be using this conductivity apparatus that will glow when there's an electric current flowing through the water. Pure water does not conduct electricity. So you can see the salt water does conduct electricity. The sugar water does not conduct electricity. And of course, the tin doesn't dissolve in water, so that didn't conduct electricity either. All right, so what about the melting points? We're going to try melting each one of these in the Bunsen burner. So first up, we've got our salt that we put into a small test tube, and we're going to torch that with a flame and give it a lot of heat to the point that things are glowing around it. But the result is that the salt does not melt in the Bunsen burner flames. Now if you get it hotter, it will melt, but it's not able to in the Bunsen burner flame. So let's try the sugar. Now those of you who have done cooking, especially if you've made creme brulee, you know sugar melts pretty easily. So let's see that in the test tube in the same way that we tested the salt. And you can see it melts very nicely and then caramelizes, and as I was doing this demonstration, it smelled like wonderful cooking, baking, just like a burnt marshmallow, or a nicely cooked marshmallow. All right, then let's try the tin. Tin's a metal. Metals are tough, right? But take a look. You can see that tin is melting in the Bunsen burner flame pretty easily, actually. So here's our results. Oh, and we can also put the tin, pour it from the test tube under the tabletop, and after a minute or two it solidifies. It goes back to the solid state. And if I wait long enough, I can even pick it up. So here's the comparison between the two, or between the three. Salt was the hardest to melt. It didn't in our demonstration, and we'd have to get up to 801 degrees Celsius to get that to melt. Sugar was the easiest. It happened so quickly I had to be careful not to torch it too hard. And that has a melting point of 146 degrees Celsius. Now tin was in the middle, and its official melting point or melting temperature is 232 degrees C. So let's take a look at these three as far as their actual bonds are concerned. If we start with the structure of salt, You can see this is two-dimensional, but it's every other atom is either sodium or chloride. So it's a beautiful crystal. It layers very nicely. And if you would go three-dimensionally, it would stack up in the third dimension there. So it's a crystal, and those crystals are very tough. Now what about sugar? Sugar forms as individual molecules, and that's one sugar molecule. So you can see it's a huge conglomeration, and there are no ions in it. So there are no ions to stack, and there's no ions to move around, and that's why it doesn't conduct electricity. Tin, on the other hand, is a bunch of tin plus 2 ions surrounded by all of the valence electrons that each tin atom is contributing to the whole thing. So the valence electrons are running around and holding the whole metal together. Metals are cool. So let me just give you a little bit of a summary for each of these. Ionic compounds are made of positive and negative ions that attract each other. They do form beautiful crystal structures that don't bend. They're rigid crystal structures. They often, but not always, dissolve in water to form solutions that conduct electricity, and you can tell which ones will dissolve by the solubility rules. They have high melting points when compared with covalent molecules, so it's hard to get them to melt. They're formed when a metal gives electrons to a nonmetal, and we've seen that those reactions can release a lot of energy. And this transfer of electrons produces the positive and negative ions that attract each other. And like it says, usually a good deal of energy. All right, then here's covalent molecules. They involve neutral atoms that are sharing electrons, and they form individual molecules like water, methane gas, CH4, carbon dioxide. Sometimes they dissolve in water, like sugar, and sometimes they don't, like wax. They have low melting points when compared with ionic compounds, so they're easier to melt. And they form different shapes. This is the VSEPR model that we'll be looking at in a later video. All right, then metals. They consist of metallic ions surrounded by a sea of electrons. They form huge malleable crystals that can bend. And that sea of electrons makes them excellent conductors of electricity and heat. And it's also the reason that they're so shiny. So metals often actually have a wide range of melting points. I chose tin because it was dramatic for the video, but if I had chosen tungsten, there's no way that my little Bunsen burner would have melted it. It has to get up to 3,400 degrees Celsius to be able to be melted. And mercury, well, mercury is already a liquid at room temperature. It has a melting point of -40. So metals have melting points anywhere between those two ranges. And as it says, we won't get into more details, but it's a great area to study. So I would recommend that you do that if you have a chance. All right, so to summarize, ionic compounds involve a transfer of electrons, and then those ions that form are attracted to each other. Covalent compounds are sharing electrons, and that'll be the focus of the next video. And then metals are held together with a sea of electrons, and again, we won't be getting very much into that, but they're really fun. Hope this has been helpful, and good luck in your studies.